Okay, part F is one of the more difficult one. Okay, some people, when they look at part F, they might think that there is an error because why a subtraction becomes a multiplication? So some people even ask me, is this an error? Okay, this is not an error. This one is one of the O-level question. And some also realize, some also will be thinking, so which one is a more complex side? So to me, the more complex side will be the one that has two terms. So this is called two terms. Multiplication is considered one term. So you should start from two terms. So you should start from the left side. And when you start from the left side, some of you might be thinking of this formula. And for those of you, if you thought of this formula, you might want to use secant square minus 1 for tangent square. So you're not wrong to think about that. But then you find that it doesn't lead you anywhere. So actually for this one, right, the formula comes from tangent x equal to sine x over cosine x. And you go and square each of them. So that is the first formula here. And after this, I try to make same denominator. So this is like over 1. So I try to make same denominator. So I got to multiply cosine square on top and bottom. So the make same denominator concept is like your sec 2. It's just that now we're making same denominator with trigo. So because of this, I got a huge fraction. After the huge fraction, I realized that there is a common factor to take out. So I actually take out a common factor. And then after I take out a common factor, okay, this is where the formula surface. This part is the tangent square. And this part is the formula. This is the formula for sine square. So I make use of making same denominator, but the requirement will be you must be choosing the correct one first. If you didn't choose this and instead you choose this, the outcome will be very different. Okay, so that's also one of the things that is difficult. The next question is quite easy, but there are some people who never realize. So the next question, right, is very obvious that the more complex one is this part. The left side is the more complex one. Okay, it's quite easy to detect, but some people, after they decide on this, right, they fail to see that there is a common factor. So you should try to recognize that there's a common factor. So I actually take that out. So after I take out a common factor, another thing, right, is to realize that this is a formula. And after you realize that this is a formula, in fact, right, this is another formula. So where the other formula come from? So remember just now, this is cosecant. So if it's a square, right, you just square everything. And then I end up as a cotangent square. Cosine square over sine square is a cotangent square. So this one has a lot of formulas. So if you can detect the take out common factor, but you couldn't match your formula, you will also get stuck. So that's why I say technique matters and the choice of formula, or to be even aware that, oh, I don't even know that there is a formula. So that's what happened to a lot of people for the proving thing. Okay, in this last two example, you will have something like a power 4. So for power 4, you will need this factorization. It's a bit like your a squared minus b squared. Okay, so like for example, in H, right? Which side do you start with? You will start with the higher power. It's easier from higher power to reduce to lower, but it's not so easy if you want to upgrade the power. So we'll start from the bigger power. Okay, so if I start from the bigger power, right? So in this case, it's something like this. So in a way, this is like A, and then this is like B. So if I use this, I will successfully factorize into two brackets. So you should relate to the formula. So I wrote it here. You should relate to this formula. And this formula allows you to manipulate. You shuffle the tangent square over. So you get a minus tangent square. So if you should relate to this formula and twist this formula. So if you twist this formula, you realize that this bracket is a 1. The second bracket turns out to be a value 1 because of the formula. Then what about the first bracket? The first bracket is not a value 1, but the first bracket is secant square is a 1 over cosine square. So it came from this formula. You go and square, square, square. Tangent square is, so there's a tangent square here. So coming from here, this one will be square, square, square. Then I make, so from here to here, you got to apply formula. And then from here to here is just same denominator. So you showed it. Okay, so if you see power 4, don't panic. You will have this kind of factorization. So the same happens on this side. So obviously you start off with your cosine 4 minus sine 4. So it's equivalent to cosine x 4 minus sine x 4. So this is like the A and this is like the B. So if you apply the factorization, you will get two brackets. And if you're very familiar, you realize that this bracket is a value 1. So one bracket kind of disappear out. So you're left with the second bracket. And that's the proof that the question wants. So look back at all this technique. The factorization technique, make same denominator technique, take out common factor technique. But you realize that also a lot relies on your choice of formula. If you are not so fluid to play around with the formula, because in your head, none of the formula is in your head, then you will find it very difficult. So I think it's a good idea if you memorize the formula. So if your teacher do make you memorize, I think that's a good idea. Or if you want to do very well, I will suggest go and memorize. Okay, so you just assume that all these formulas, right, will not be given to you. Okay, well, it's true to a certain extent. Only the O-level formula is given to you. So you look back at those techniques and see whether you can try the subsequent question with all these techniques.